AI hallucinations are different from human hallucinations, as they produce incorrect results that are significantly different from reality or the given context. For example, an AI chatbot may respond illogically or identify an object wrongly. Due to noise or structural problems, these hallucinations arise from insufficient or inadequate data used to train and design the AI system, and are not due to a conscious or subconscious mind. Imagine you're training a computer program to create something new, like a picture or a sentence. But sometimes, even though the program was only supposed to use certain types of data, it creates something that doesn't make sense or even seems strange. This is called a hallucination in the world of AI. It might seem like a small issue, but for businesses that rely on these programs to create content, it can be a big problem. These hallucinations can cause inaccuracies, inconsistencies, and even errors that can hurt the customer experience. In some cases, they can even be dangerous. Like if a medical program generates incorrect instructions for a patient. Hallucinations in generative AI are categorized as intrinsic and extrinsic. Intrinsic hallucinations are generated outputs that contradict the source content, while extrinsic hallucinations are outputs that cannot be verified from the source. Extrinsic hallucinations may contain factually correct information from external sources, but their unverifiable nature makes them risky. It's important to understand what causes these hallucinations and how to prevent them. Insufficient or biased data. If the data used to train the AI is not diverse or accurate, AI may produce hallucinations. Improper optimization. The AI must be calibrated properly to generate coherent output. If not, it may generate nonsensical phrases or images. Lack of diversity in training data. The AI needs diverse data to produce accurate and diverse output. If not, it may generate output that is not what is desired. Input data outside the scope of training data. The AI is designed to work within a certain range. If the input data is outside that range, it may produce bizarre output. Hallucinations can have several negative impacts on the accuracy and reliability of generative AI models. Reduced accuracy. If a generative AI model produces hallucinations, it may also produce inaccurate output. This can be problematic for businesses that rely on AI-generated content for tasks such as image recognition or natural language processing. Reduced reliability. Hallucinations can also make generative AI models less reliable. If an AI model produces different output each time it is run, it can be difficult to trust the output or use it for important decision-making. Negative impact on customer experience. If hallucinations lead to inaccurate or unreliable output, they can also negatively impact the customer experience. For example, AI-powered virtual reality experience that generates hallucinatory images or sounds could be off-putting or even scary for users. Legal and ethical concerns. If AI-generated content is used in industries such as healthcare or finance, hallucinations could have legal or ethical implications. For example, if an AI model generates a hallucination that leads to an incorrect medical diagnosis, it could have serious consequences. Hallucinations are like a false alarm in your brain, causing you to perceive things that aren't really there. Similarly, in AI, generative algorithms can produce unexpected and strange outputs that aren't based on any real information, known as AI hallucinations. These occur due to abnormalities or errors in data processing, leading to the generation of false or unrealistic outputs. Both human and AI hallucinations can result from gaps in knowledge or abnormalities in processing, causing the perception of TNGs that aren't really there. Mitigation methods can be divided into two categories: data-related methods and modeling and inference methods. Data-related methods. Greater than one approach is to build a faithful dataset by manually constructing clean and diverse targets, either from scratch or by rewriting real sentences. Another approach is to automatically clean data by filtering or correcting irrelevant or contradictory information in the existing corpus. Instance-level scores can be used to filter out hallucinated samples, while data-to-text tasks can correct paired training samples by utilizing a model to extract meaning representations from human references. Augmenting inputs with external information, such as entity information, relation, triples, or retrieved knowledge, can also improve alignment and alleviate divergence from the source, but can also pose challenges due to semantic and format discrepancies. These methods can help businesses improve the accuracy and reliability of their AI-generated content, providing a better experience for their customers. Test and validate to make sure AI models are accurate and reliable. Regularly test and validate them using separate datasets. It's like giving your AI a reality check. Modeling and inference methods. Businesses see and modify the architecture of the model. For example, a dual encoder, consisting of a sequential document encoder and a structured graph encoder, can improve the representation of the input. The attention mechanism can also be adjusted to encourage the generator to focus more on the source and less on irrelevant information. The decoder, which generates the final output, can be modified to reduce randomness and improve the accuracy of the output. These modifications can help balance the need for faithful tokens while reducing the risk of hallucinations. Different methods are used in natural language generation to reduce the problem of hallucinations. Planning and sketching allow for greater control over generated content, while reinforcement learning uses reward DS to optimize models. Multitask learning trains a shared model on multiple tasks to improve learning, while controllable generation techniques use control codes to adjust the level of hallucination. Other methods such as regularization and loss reconstruction have also been proposed. Refine and optimize. Researchers are developing new AI architectures that are better suited for specific generative tasks. So, refine and optimize your model to reduce the likelihood of hallucinations. Post-processing techniques. Use post-processing techniques to filter out hallucinations from AI generated output. It's like putting a filter on your AI's creativity. Be aware of limitations. It's essential to be aware of the limitations of generative AI and use it in contexts where the risks of hallucinations are minimal. Think about using generative AI for entertainment or creative applications rather than mission-critical tasks. AI is becoming more common in our everyday lives, but it can sometimes make mistakes, which can be dangerous, especially in self-driving cars. Here are some ways to identify AI mistakes. Look out for grammatical errors or text that doesn't make sense, as this could indicate an AI hallucination in language. AI can make mistakes if it hasn't been trained with enough visual data. It might think a tennis ball is a different color or mistake a statue for a real animal. Comparing AI output to what a normal human would observe can help spot these. Self-driving cars use AI to make decisions. Understanding how AI perceives the environment, like looking at Tesla Autopilot, can help you understand its limitations and avoid any dangerous mistakes. A few simple stickers on a stop sign are enough to render it invisible to a machine vision algorithm, while to human eyes it is still obvious.